Hello, I've got what will be an extremely short video here on acceleration, just the basis of what acceleration is. A lot of people talk about acceleration, and it's sort of in our everyday lives. We know that if I were to start at a stoplight and I slam on my gas pedals, put it down as hard as I can, then I'm going to accelerate. But acceleration can actually take on a few more forms than that. But in essence, you see here the definition of acceleration, so make sure you get it written down. But acceleration is a vector, so you get used to those. We have a lot of vectors in physics. But acceleration is a vector quantity describing the rate that velocity is changing. So an acceleration is simply a change in velocity. Now, velocity itself is a change in displacement. So we get this kind of weird stacking effect where acceleration is the change in displacement. But look at it like this. Acceleration is equal to delta V over delta T. Again, we discussed delta, that Greek letter. It represents the change or the difference in something. So we have the difference in velocity, so the final velocity minus the initial velocity divided by the time. This equation looks very similar to velocity. Acceleration and velocity have this really special, sort of unique relationship that we'll look at soon, but they are related, and this is why you see this kind of stacking here. It looks almost exactly like a velocity equation, right? Except velocity said it was the change in displacement over the change in time. So acceleration is a rate of change of velocity. And let's look really quick. Maybe we'll do one example here. The units for acceleration, I want to look at those really quick. Again, anytime we want to look at the units, we just plug in our units into the equation. So you have meters per, well, let me start. It's the velocity final minus the velocity initial divided by the time. Or in this case, you have final velocity minus initial velocity is just going to yield some velocity. So in terms of units, these are on top are going to be meters per second divided by time is in seconds. So you have meters per second divided by seconds. Well, maybe it's been a while since you've divided fractions, but it's really easy to do. All you do when you divide fractions, this is the same as meters per second multiplied by the inverse. So times the reciprocal.
Mr. Brace, call the office, please. Mr. Brace.
And now multiply across the top, meters over seconds times seconds is seconds squared. So in other words, the units of acceleration are meters per second squared. And understand that this is just a unit. You're not actually squaring any numbers. If I'm accelerating at 2 meters per second squared, you don't actually square 2 or anything. It's just part of the name. Like my last name is King, but that doesn't mean that I get to give royal proclamations and declare what is and is not right or wrong or just. I don't get those powers just because my last name is King. If your last name is Carpenter, it doesn't mean you know how to build a house. It's just that's your last name. Here, you don't actually square anything. That's just part of the name of the unit. It's meters per second squared. Nothing actually gets squared. Sometimes students will struggle with that. Let's look at a real quick problem here. So here it says a car speeding on a highway at a velocity of 15 meters per second south sees a police car. The car then puts on its brakes and 2 seconds later is moving at 10 meters per second south. Find the acceleration of the car. So when you talk about acceleration, again, it's a vector, so you have to be very careful with these velocities are vectors as well. So you have to be very careful when you plug these in. The final velocity is, let's see, 10 meters south. So I'm not just going to write 10, I'm going to write negative 10. Minus the initial velocity. It began at 15 meters south, so negative 15 meters per second. I know there's a lot of negatives here, but just be really careful. Divided by the time, which is 2 seconds. Now time is a scalar. I don't really have to worry about a positive or negative time. It just is. So this will become, I'll add these, so negative 10 plus positive 15 gives me 5 meters per second divided by 2 seconds, and 5 divided by 2 is 2.5 meters per second squared, and that is my acceleration. Notice that the acceleration is positive, so he's actually accelerating in the positive direction. which means he's accelerating. We're talking about north and south, so it looks like he's actually accelerating this in the north direction. But since he was moving south, right, I mean, he's moving down, it says here he's moving south, so imagine this is my car. As I'm moving south, I'm going to start to put on the brakes, so I'm slowing down, which we typically don't think of as acceleration, but here we see that it is a change in velocity, so it is an acceleration. It's just he's accelerating in the other direction. If I'm slowing down, I'm accelerating in the other direction. If I kept going on that same track, eventually I would stop and go back up. So hopefully you watch my mouse there, but again, I said I was going to keep it short. This is basically what I want to go over. If you watch this, make sure you need to text 2 friends and make sure that they watch it so that they have their homework done as well. Thank you.